See Elegans Maintenance. This video series includes preparing LB agar, seeding LB agar, preparing LB broth, seeding NGM plates, and chunking. This video is preparing LB agar. The materials you need are the following: a distilled water, LB agar, a volumetric flask, reagent bottle, and other necessary materials, such as weigh boats, scoopers, and funnels. For the distilled water, pro tip is to make the distilled water prior to your experiments to ensure that you have the amount necessary for your solution. Alrighty, the next is that the LB agar also has the ratio of 40 grams to 1 liter, so be sure to do the calculations necessary to figure out how much you need for your solution. Next, to find the volumetric flask, locate them in the primary lab in Ms. Shofi's room above the area near the pipettes. Make sure that it's clean and not only sterilized but washed. You will also need a reagent bottle, and that does not need to be sterilized because the LB agar will be sterilized during this procedure. Lastly, you will need petri dishes. Step 1 is measuring the LB agar powder. So like I mentioned before, be sure that your calculations are correct for the amount that you'll need. For this, we are going to need about 10 grams. Make sure to zero the electric balance to ensure that you're measuring the right amount. So use a scooper to measure the amount of LB agar powder that you'll need. Make sure to keep a close eye on it so that you do not go over and need to scoop out. Okay, now that we've achieved 10 grams, step 2 is to pour the LB agar into the volumetric flask using a funnel. So, pour the powder from the weigh boat into the volumetric flask using the funnel. Be sure to tap to ensure that the majority of the powder is able to go into the funnel. And then with the excess, use a little bit of water and be sure that it's fully distilled and is the same water that you will use later in order to get the excess that is stuck to the weigh boat. In this case, we use the entire water distiller container because the other bottle was currently dirty, but in future cases be sure to use the smaller squirter bottle of distilled water. Fill the volumetric flask up into about a little bit up into the volumetric flask and then stir until you have a completely liquidized solution with no chunks. Now, once you are going to be pouring back into the reagent bottle, make sure it's labeled with the name, the contents, and the date that it was prepared. Pour using a funnel and the volumetric flask, but ensure that before this occurs, you fill to the meniscus line. A pro tip is to stir a volumetric flask once the solution starts to get low to make sure that you're getting all of the excess at the bottom of the volumetric flask. Step 3 is autoclaving. Make sure to get the autoclave tape to put on your reagent bottle so that you or anybody else who accesses the autoclave knows whether it has been autoclaved or not. And then another pro tip is to make sure that your lid is not fully securely fastened, as that may cause a buildup and possibly an explosion. So just tighten it a little bit and make sure that it won't fall off, but make sure that air can still release. And then check the autoclave, make sure that it's on. Also ensure that you have the adequate amount of water. As you can see here, there is a particular line that it should meet. And when it doesn't, get some water from the tap using a beaker or another container to pour up to as much as necessary. Now, be sure to check this every time. Close the water container, open the autoclave, and put the necessary materials inside. Here we actually decided to add a few more reagent bottles for future solutions. Now seal it completely tight. If you can't move it any further, that's just tight enough. And click start, and you are a go. Make sure that you have blocked out the autoclave scheduling prior to starting your procedure because it often takes more time than you expect and other people may also need to use the autoclave. So be conscious and be a thoughtful scientist. Two hours later, open the autoclave and make sure you have a heat glove because Be careful, it's hot. Grab it and take it over to the biological safety cabinet because that is the most sterile. Location in the lab. Another pro tip is to make sure that you've wiped it down and use the UV light in order to cleanse the inside of the biological safety cabinet. Though this is not pictured, it's something that we did complete prior to ensure sterility. Step 4 is pouring plates. So, because it's hot, you must wait until it's adequately cooled for you to carry it, but not too cold that the LB agar begins to congeal. Once it's reached this temperature, which is something that's up to you in terms of what you can handle with heat, start pouring until about the median line of the petri dish. However many LB plates that you plan to make. And another pro tip is to fully use all of the LB agar that you've prepared because it's very difficult to clean out of the reagent bottles once it has congealed. Lastly, to ensure full sterility, wrap all of your plates in parafilm wax and stretch it over as best as possible. Step 5 is incubation, so it should be set at 37 degrees Celsius and placed inside of the incubator. Another pro tip is that prior to parafilming and even pouring some of your LB plate, turn on the incubator and set it to 37 degrees Celsius because it does take some time to count up. Step 6 is seeding LB agar plates. So first, be sure to make sure you have your inoculating loops, your OP50 or whichever E. coli you'll be using, and also be sure that you have your LB agar plates here. So the first step, as illustrated here, is to swab the OP50 and then to swab very gently on the LB agar and ensure that it is gentle to make sure that there is no puncture of the LB gel. Lastly, parafilm and set your incubator to 37 degrees Celsius and place your LB plates newly seeded into the incubator. Lastly, for storage, once your plates have grown for about 24 hours, place them in the refrigerator and they will be useful for however long you need them. This section of the video is on preparing and seeding LB broth. The materials you will need is the LB broth powder, reagent bottles, weigh boats, scoopers, funnels, volumetric flasks, distilled water, and an electronic balance. Be sure to stir throughout the pouring process to ensure that no residue is left over within the volumetric flask. Step 2 is to autoclave. So make sure that the caps are not fully sealed, and once they've all been placed, seal the autoclave fully. Make sure it is very tight, and you are complete. Step 3 is making the broth. So peel the autoclave tape off, and next bring your LB agar from the refrigerator, your LB broth, and an inoculating loop into the biological safety cabinet. Set the biological safety cabinet on to make sure that it is fully sterile. Once you have done so, unwrap your kneaded LB agar and open your reagent bottle. So, swab very gently on the LB agar plates, and here you can see an inoculating loop with the E. coli on it. Once you've done so, stir very thoroughly within the LB broth solution to make sure that all of the E. coli has been distributed throughout. Once you've done so, seal both the LB agar plates and the LB broth solution. The LB agar can be placed back in the refrigerator, and step 4 is to place the LB broth solution in an incubator set at 37 degrees. This section of the video is on seeding NGM plates. The materials you will need are NGM plates, microcentrifuge tubes set at 50 microliters, microcentrifuge tips, preferably sterilized, and seeded LB agar. You may also need ethanol to wipe down any surfaces to ensure aseptic technique. So the first step is to use your sterilized tips and plunge them into your LB agar. Pro tip, make sure that it's stirred to ensure that there is equal distribution of the E. coli. Once you've acquired 50 microliters of the LB agar seeded, pipette that into the center of the NGM plate and rotate it slightly to ensure that there is a distribution of the E. coli so that once it's been incubated, it creates a lawn. Follow this step with any of the NGM plates that you need. And once this has been accomplished, parafilm wrap your NGM plates to ensure sterility. Place your newly seeded NGM plates wrapped in parafilm in an incubator set to 37 degrees Celsius. This section of the video is on chunking. The materials you will need are a scalpel, scalpel tips, a scalpel tip remover, seeded NGM plates, a batch of C. elegans, and ethanol in order to sterilize the scalpel. Begin by removing your scalpel tip from its wrap and placing it on your scalpel. Do your best not to touch the tip of the scalpel and ensure that your gloves have not been exposed to any contaminated surfaces. Once you have done so, or more likely had a partner do so, open your seeded NGM plates and ensure that there is a lawn of E. coli growing on each of the plates. It should look like a bit of a cloudy surface within your NGM plate. Next, observe the C. elegans plate that was sent to you under a microscope. Here you can see that the C. elegans are evenly distributed and they can be acquired from any part of the plate, but just in case that they're not evenly distributed and they've sort of concentrated around one section, be sure to check so that you don't chunk without any C. elegans on the plate. Cut a triangular shape into the C. elegans plate that was sent to you and use the scalpel to scoop it out. Then make sure that once you're placing it into your NGM plates that you flip it over so that the side that the C. elegans are growing on is touching the lawn and the surface of your NGM plate. This can be a bit of a difficult process, so use the side of your petri dish in order to sort of swipe it off and push down the chunk that you've cut. Repeat this process with any of the petri dishes that you may need. Once you've done so, wrap your petri dishes in parafilm and place it in an incubator set anywhere between, I believe, 16 to 22. For this experiment, we set it to 20 Celsius because that's what's necessary for the growing cycle, but this will need to be individualized per experiment. Alrighty, thank you for watching. See you in the next video. Bye!